Assalamu alaikum. In this video we will discuss decimal to binary conversion. The conversion from decimal to binary or to any other base R system is more convenient if a number is separated into two parts, integer part and a fraction part. Integer part and fraction. And then the conversion for each part is done separately. For this one will be done separately and for this one will be done separately. In this video we will focus on integer part, while this fraction part will be put on engineering table in coming videos inshallah. So the conversion of an integer from decimal to binary is best explained by example. So let's jump into an example. Let's take our first example, that is we have to convert this decimal 41 to binary. In order to do so, we will have something to write. First 41 is divided by 2 to give an integer quotient of 20 and a remainder of 1 by 2. The quotient, this one, is again divided by 2, 20 by 2. In this case 10 will be our integer quotient and the remainder will be 0. The quotient is again divided by 2. In this case the integer quotient is 5 and remainder is 0. Now again this 5 is divided by 2. The integer quotient will be 2 with the remainder of 1 by 2, and again divided this one by 2. So the integer quotient will be 1 and the remainder will be 0. Finally this one is divided by 2. This one is again divided by 2 to give a quotient of 0, as 1 is not divided by 2, and a remainder of 1. Okay, now we have to write these coefficients. This is the column of a coefficients, and here you must take a quick look at this thing, that the first one will be a sub 0, this one will be a sub 1, this one will be a sub 2, this one will be a sub 3, this one will be a sub 4, and this one will be a sub 6. So in this case coefficient will be 1, and for this it will be 0, 0, and here also 1 and 0 and 1. Okay, sorry, this is actually a sub 5. Okay, a sub 4 and this one is a sub 5. So if you do remember, we always write these numbers a sub 0, a sub 1, a sub 2 from. You can also write in this way. Okay, so 1 0 1 0 0 1. Decimal 41 has an binary equivalent of 1 0 1 0 0 1. Now the arithmetic process can be manipulated more conveniently as let me write integer and remainder. 41 is all that must be translated into binary number, and when it is divided by 2, it will integer will be 20 and the remainder will be 1. Again divided this 20 by 2, it will get us 10, and by then the remainder will be 0. Now again dividing this 10 by 2, which will get us 5, and the remainder will be 0. Now again dividing by 2 will get us 2, and remainder will be 1, and when this 2 is divided by 2, it will get us 1 and the remainder will be 0. And finally when this one is divided by 2, the integer will be 0 and remainder will be 1. So all you need to write this sequence starting from this, from down to up. Here I will get 1 0 1 0 0 1. So this decimal number 41 has a binary equivalent of 101001. Okay. Before going into a next example, it is necessary that let's verify what we have done, that whether this number is really equal to 41 or not. To do so, is I have show how to convert binary number or any number to a decimal. So what you need to do, that we have to multiply this one, these coefficients with this 2. So let me do it quickly. So 2 plus 0 into 2 plus 0 into 2 plus this one into 2 plus 0 into 2 plus 1 into 2. Now taking start from here, 0, this 2 will have power of 0, this one will have 1, this one have 2, 3, 4 and 5. Okay, so this get us 32. This will be zeros, plus this will 8, plus only this one 1 into 1 will get us 1. So finally, so yes, you can see that this binary number is equal to 41. This was verification. Here one thing is important to tell, that the conversion from any decimal integer to any base R system is similar to these example, except that division is done by R instead of 2. As we are here, we have to convert it to binary, so we have done the division by 2 over here. Now if I have to convert this number to a ternary number, what will I do? I will divide it by 3. So let me take an example of this one. Let's translate this decimal number 86 to ternary number. The process will be same as I told. So here quotient, and in this column we have remainders. So here we have 86, and when 86 is divided by 3, I will get 28, and 2 will be remainder. Okay, as 28 3s are 84, so the remainder is 2, and now divided by again this by 3. This all will be divided by 3. 28 divided by 3 will get us 9, and 9 3s are 27, and 1 will be remainder. Now again dividing this one by 3, which will get us 3 3s are 9, and remainder will be 0. And when 3 is divided by 3, we will get 1, and remainder is 0. And finally, when 1 is divided by 3, it will get us 0, and remainder will be 1. Okay, now writing it that way, this decimal 86 has equivalent of 10012. Okay, you can verify it if we have to verify it. So let's do this. And order to verify this, and all these coefficients will be multiplied with this base, 2 into 3 plus 1 into 3 plus 0 into 3 plus 0 into 3 plus 1 into 3. These are the coefficients you can see in above. It's equivalent. We are just verifying it. Now starting from here, 3 will have a power of 0, 1, 2, 3 and 4. Now this, you can say, this will get us 3 3s are 9, 9 3s are 27, 27 3s are 81, plus these turn out to be zeros, these, and this one will 3, plus this one is 3, and this turn out to be 1, so 2 1s are 2. So we get 5 84, 84 plus 2 will get us 86. So you can see. Okay, This is verified. Now at last, let's concluded our this tutorial at this example, and in this example we will convert decimal 153 to octal, okay, to base 8. So here the required base r is 8. We have to do this. So first 153, all these quotient column is gonna divide by 8, okay. There's, here we have r and the remainder. This is remainder column. When 153 is divided by 8, 19, and the remainder will be 1. Again divide 19 by 8 will 2, quotient will be 2, and the remainder will be 3. And finally when 2 is divided by 8 to give a quotient of 0, and 2 will be a remainder. So we have to write it in this way. So 2, 3, 1 to base 8 is octal of decimal 153. So after these examples we come to know that the convergence from decimal to any base, from decimal to any base r, to any base r system is similar to these example, except that what we have done, that we have done here division by 8. So whatever the decimal number may be, if you have to translate it, you will have to divide it by that number in r, okay. So that's the simple rule. See you in next lecture, and I will mention some homework, so mention its answer in the comment section. Thank you. See you in next lecture. Alhamdulillah, 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 alhamdulillah. Allahu Akbar.